19 days, 1 sale. 15 days, 2 sales. 21 days, 3 sales. 9 days, 4 sales. So I'm looking at sales per day and how many days they had that. How do I find the probability of 0 days coming up? I want to trend this guy. So this guy, or what was this scenario? I forget what it even was. It was like a whole thing. We did this. Okay, let me just make sure I'm saying it. This was a company. They tracked the number of sales per day during a 100-day probationary period for each employee. The results from one employee are shown here. So out of 100 days, 16 of those days he made no sales. Sound good? So we want to track this. Once we figure out this trend, we want to see, well, what is the probability of today that he actually makes 1 sale? We use this information to help us forecast our probability. So we know that, what does this column have to add up to? 100. We did this for 100 days, which makes our life very nice. So probability is part over whole. Part for the 0 days, for the 1 day, for the 2 day, I'm going to take all their parts and put it over the total. This is the same as your relative frequency. So for each one of these, I'm taking the part over the whole. Stay in that column. For 1, I want 19 over 100. For 2, I want 15 over 100. And out of 100, this decimal is very nice. It just converts to the decimal because it's hundredths. So all the way down, here's my decimal. 9 is 0.09 because it's 9 hundredths, 0.09. And these have to add up to what? All those decimals? 1. Okay, so I can look at my new employee and say he has a 16% chance of making no sales today. He has a 21% chance of making 3 sales today. So I'm using my probability of when things happen to help also predict what will happen in his future. He has a 10% chance of making 5 sales per day. So this is the trending part of it. This is what probabilities are. What's the probability that he will make 3 sales today? So 3 sales, 21%. I tracked him for 100 days. Now, in your calculator, if you put L1, L2, so let's try this again. Out of these 3 rows, L1, L2, and make sure you 1-bear stack L1, L2. The last 3 rows, I want L1, L2. And we're going to do this last column last. So these guys are getting a mean and a standard deviation and a sample standard deviation. These guys are getting a mean and a standard deviation and a sample standard deviation. Make sure you tell your calculator that you're using a frequency. Otherwise, it doesn't know that. Before I had kids, I was a programmer analyst. And one of the biggest things we learned with ego, G-I-G-O, garbage in, garbage out. The computer is only as smart as you make it. So if you tell it what to do, it only knows what you told it. So you can't say, oh, my calculator said this. It's you that put it in. So, anybody get a mean here? 2.6. A population standard deviation?
1.9.
A sample standard deviation? 1.9.
Oh, like the OX is not 1.938.
So 1.94 and 1.9 sample is 1.
Oh, yeah, the other way. The other way.
This is a 4, and this was a what? What was your population?
That was 1.3.
One-
1.93.
1.93. Okay. Okay, my calculator, my board is a little bit off, as usual. This time it's on this side. Last time it was always on that side. Okay, let's look at the red curve. Red side. What'd you get for a mean? Mike, get a mean?
Yeah, I got 2.6.
2.6?
Yeah.
Good. And your population standard deviation?
1.93.
Good. And your sample?
I didn't get that.
None. Right. So far they match, right? Okay, now, according to the table, we should be able to multiply x by p times x. This is your x, this is your p times x. If we multiply these two things, we get this. So let's multiply these across. We're going to multiply x times my probability. So 0 times this, 0. 1 times this, 0.19. 2 times this, 3. 3.63. 4, 5, we're doing pretty good so far. And 0.14. Now, when you take the sum of this is equal to the mean. This is another way to find your mean. So let's add that column down and see, in fact, if we get the 2.6. All of these should be the same. All of my standard deviations should be the same. Where'd we at? Anybody add them up? 2.6? Okay, so we have a couple of different ways to do this. If you like the chart way, you can always do the chart way. However, to find the standard deviation, you're going to have to put it in your calculator anyway. So I show you this, but I really don't use it to find the mean, because unless you want to make that big long table to find standard deviation, you're going to put this in your L1, L2. We have a calculator, that's what we use. You can put this in your L1, L2. You can put this in your L1, L2. Okay, just remember that when you use a decimal, it's not wrong that you didn't get a sample standard deviation. It just cannot divide by 0. To make your graph, which you'll see on your quiz as well, when we make our graph, we're using, instead of a frequency, this is where you have to use the P of X. It's like your relative frequency chart. So down here are your X values. These are sales per day. This is your probability of that happening. And you're going to just make your Y go from this column only. The highest is like 20 cents, 25 cents. So you can 0.05 again. Think money when you do this. It's the easiest way to set it up. Give it a title, sales per day up there, and make your bars. So this would be 16 cents. Just think money. The bars have to touch. 19 cents, 15 cents. Just think money. 21 cents. And you'll make your bars. 9. This one has a little bit of a tail. Let's bring this down. 10, 8, and 2. This one's got a little bit of a skew to it. A little bit of a skew. Okay? We just follow the tail. It doesn't follow the normal curve, but a lot of things don't follow the normal curve. Are we okay with this? This is like the whole crux of this chapter, is looking at probabilities, finding the probability of something happening, finding the mean, the standard deviation, looking at your graph, seeing, is it a normal looking graph, a normal curve? Is it a little bit of a skew? This one has a little bit of a skew to it. Standard deviation, we're not going to make their chart. We're gonna use our calculator. They do give you, if you look in your book, and I don't want to spend a lot of time with this, because we did the big chart once. As long as we did it once already, I don't really need to do it again. It's not something that you're going to remember, and it's not something that you're going to see used in the industry. Everybody uses some kind of a software program. If you take a look on page 195, there's the way we found standard deviations before. They just have a little bit of a twist to it because they have a probability in there. We took the difference of the means, we squared it, and then they multiplied the square times the probability of it happening, and the rest of the standard deviation pretty much works the same. So we're bypassing doing that chart because we're using our calculator. Make sense? So everybody do this. What if I asked you now, if I said to you, what is the probability that this guy will work, that this guy will make 4 or more sales per day? Good. Just come down and you add these up. What am I going to add? The PX. Very good. So I'm adding the 0.09 plus 0.10 plus 0.8 plus 0.02. Okay? I'm adding that, and that gives me the probability. Do I have to divide or do anything else? Nope. I already have the probabilities. This isn't or statement. 4 or more. This is mutually exclusive, this table. If he makes 4, that means he didn't make 5. If he makes 5, that means we don't count 4. They're separate little groups. What's the probability that he makes 2 or 7 sales per day? 0.17 or 17%. There's a 17% probability that he will make 2 or 7 sales per day. Doesn't really make sense to say it, but that's how we can use our chart. What's the probability that he makes less than 3? Less than 3 sales today. What do I have to add? Do I count 3? Nope. 2 or less. So I come over here and I add these up. There's a pretty strong probability that he'll make 2, 3, or less than 3, right? 50%. That's a pretty strong probability. Okay. So you can use this chart to figure out your probabilities. Make sense? Okay. All right. So one last part to this is expected value. Expected value, let me shrink this down a little bit. Whoops. You have it on your note page, and I apologize to you guys that don't have the note page. I honestly don't know why I didn't have that copy. So expected value is the last part of this. When people are figuring out odds, they want to know, what do I get back? What is my net gain? If I have a net loss, is it worth doing it? So if I have a net gain, it is worth it. If my net gain is not that big, do I want to take a chance? Probably not. At least I want to make sure I have some kind of a net gain. So if you take a look at this, the expected value of a discrete random variable is equal to the mean of that random variable. So again, I'm going to walk you through this. You can put this in your L1, put this in your L2, and find out the mean. So this is key right here. We can still use your L1. We can still use your L2 table. We'll walk through how they like us to do it. And then we can always do it ourselves. So at a raffle, 1,500 tickets are sold at $2 each for 4 prizes of $500, $250, $150, and $75. You buy 1 ticket. What is your expected value of your game? Now, don't forget, you already put this cost in. That cost you put out. So if you win $500, you really didn't win 500, right? You won 500 minus your investment. So you really won 498. Still a good little bit of money there. But anytime from this, you spent your $2. So this you'll win 498. This you'll win 248. We're taking away your $2. This you'll win 148, and this you'll win 73. Now, if you don't win, what happens? You're out $2. There's your minus 2. Okay? So there's only 4 tickets that are winners out of 1,500. So each one of these guys has a 1 out of 1,500 chance of winning.
What odds?
The odds are not good. But then again, you're only spending $2. So if I take out the 4 possible winners, that's where this number comes from. Because you have 1,500 possible tickets. 4 of them are winners. 1,496 are not winners. They're losers. Okay? So now, how do you figure out expected value? So what they want us to do now is they don't have another line here, but they do this. They do the x times the p of x. Isn't this how we found our mean? X times the p of x? And then we added all those up to find the mean? So this is how expected value works, the same way. I multiply this, 498, times 1 over 1,500. I multiply 248 times 1 over 1,500. So it's the same as your probability, kind of. So I multiply these guys, x times p of x, and when I get all of these, I add them up, and that's my mean, that's my expected value. So if you work with your chart, rather than multiply this in my head, they should have given us another little space there, but they didn't. So this, if you add all these up, and you multiply this, don't forget this is the negative. So if you put this whole thing in your calculator, because you're going to add these all up, and you add these guys, and you add this one, and you subtract that, this comes out to be an average net loss of $1.35 per ticket. That means you can expect to lose an average of $1.35 for every ticket that you buy. If you bought all the tickets, what do these guys add up to? Add these in your calculator. $9.75. Right? You can only win back $9.75 in total. Is this a good deal? Out of 1,500 tickets, and you're spending $2 a ticket. If you bought every ticket, how much? If you just say, okay, I'm just buying all these tickets, I gotta win. You had to spend $3,000. Overall, are you a winner? So your net, if you bought them all, your net loss is $1.35 per ticket. Right? Wouldn't this number have to be a lot higher? This would have to be a lot higher for you to get a gain. And that's theoretically if you bought every single ticket. But in theory, what I want you to get out of this is that your expected value is equal to your mean. Do we have to do this? We don't have to do this. We can still put this in our L1, our L2, and find the mean. Okay, I mean, it's nice to do it this way because you actually see what's happening and you can see how much money you stand to gain because you paid the $2, how much money you stand to gain, and then all the other tickets are losers. You still pay $2 to lose that. So overall, I'm not liking those odds. Who didn't like those odds? Chris? Chris didn't like those odds. Chris was right. We didn't like those odds. Okay. We don't do that much with expected value. If you go into probability, this is a major part of probability. When people set up games, they want to know like who's going to be the winner here. If you even like go to those online things or even play those chance games and play those poker things or whatever they have out there, you're not designed to win. So, like, figure out Vegas. They'd be bankrupt, wouldn't they?
Yeah.
Their goal is to win as much as they can. So you're not expected to win. You get lucky. Yeah, people get lucky. But overall, people are not big winners. Again, we can set this one up. At a raffle, there are 2,000 tickets sold at $5 each for these prizes. So again, if you figure out your prizes, $2,000, $3,000, $3,075, how much are you going to spend if you bought each one of these?
Too much.
Too much. You're spending $10,000, right? 2,000 times 5 to win back, what did we just say? $3,700, $3,750, whatever that was. So are you expected to be a big winner? No. You're going to be a big loser if you buy all of those tickets. But at least you won, right? At least you can say you won. So again, to set this up, I kind of already set it up so we can go by this. So you take each one of these tickets. This only has a one chance to win. This has a one chance to win, one chance to win, one chance to win. But you paid $5 for this. So my net win is $2,000 minus $5. My net win is $1,000 minus $5. Here's my net loss. All those other tickets are losers. So now, if you figure it out just logically, this is going to cost you $10,000 to buy every single ticket. And if I add up the prizes, that's $3,750. Well,
Wow.
that's like a third of it. So look where your net loss is. Look at my net loss. $3 per ticket. Wouldn't that make sense? That's like a third of it, isn't it? Yeah. I have to be a net loser. The only thing that would make me be a net gain is if my prizes added up to more than I spent. Right? If they did like 12,000 plus 10,000 plus 5,000 plus 2,500. If they added up to more, I'd be a net winner. But if they give me this, I'm a net loser. So to find these, you're going to put this in your L1. You're going to put this in your L2. You have to figure out your probabilities, but that we can do because out of 2,000 tickets sold, there's only one of these guys. There's only one of this prize. One of this prize, one of this prize, one of this prize. This is my complement. My 2,000 minus 5 winners. This is what's left over. This is if I don't win. I've already spent my $5. So that's the only part you're really going to have to figure out is those probabilities. To make it a net gain, net loss. Sound good? All right. So what we're going to do here is I'm going to give you a couple to try from home. Let's do this. I gotta get over here. Okay,